There are many types of exoplanets. Some of them are solid and terrestrial, and some of them are gas giants. But what about those that are not solid on the surface, but neither are gas giants? I'm talking about oceanic exoplanets. So let's take a look at some of them and see what swimming in the ocean of one of these oceanic planets would be like. But before we look at them, it's important to note that these are rough estimates and they may not be fully oceanic. But through using the data we know, such as if the planet is in the habitable zone or if it has the right mass, we also know that water is one of the most common molecules in the universe. It appears everywhere. Like a lot of moons in the solar system have oceans beneath them, so oceans should be prevalent through an uncountable number of planets. And including other small factors, we can roughly estimate if they have oceans. One of these thought to be oceanic planets is Kepler 22b. It is 600 light years away, so it is 600 years in the past from our point of view. It orbits a star called Kepler 22, and it is the only known planet in the system. But its parent star is a bit fainter and smaller than our Sun. Still, Kepler 22b is in the habitable zone. It is still around 30 times more massive than the Earth is, and it has around double the radius that the Earth has. Basically, this is a giant planet. So, let's go and swim in the oceans of the planet. So, as you would be landing, you likely would see huge thick clouds that would cover a bit of the surface. Going out and splashing it into the water would be a bit weird, because the gravity of the planet is a lot stronger, so you would feel very heavy, and swimming would be hard, but possible. Also, as you would splash around, you would notice that the water is falling down a lot faster. If there is not a lot of oxygen, or if there is too much carbon dioxide, then you would need to wear an oxygen tank with you. The temperature of the water would be likely at around 20 Celsius, as that is the estimate of how much would the atmosphere be hot if it had the same greenhouse effect as the Earth does. But the temperature could be higher or colder. Diving and looking down, you would see a pitch black void, as the depths of a fully covered oceanic planet would be extreme, so it would be quite scary. While swimming and looking up into the sky, if it would be filled with oxygen, carbon dioxide and water vapor, which likely is the case for an oceanic planet, then the sky would be blue, or gray if it is covered by clouds. There is also a chance that some life form evolved there, but you may not be able to spot it, as it may be just single-celled life. Now let's take a look at other oceanic planets. So there are also two possibly oceanic worlds in one system, and that is Kepler 62. It is a star 7 billion years old, which is a lot older than our Sun, but it is also less luminous and smaller. The star is 1,200 light years away. Still, there are 5 found planets in the system, of which 2 are 62e and 62f, and they may be oceanic. They are in the habitable zone and have the right masses. So that and other little factors make us think that they could be very much oceanic. So, there even was a modeling study that indicated that majority of the planets in Kepler 62f's size are covered with oceans. Now let's take a look at the closest planet that could be possibly an oceanic world, and that is Glese 1214b. It is 42 light years away, which is still an unreachable distance, but it is many times closer compared to other oceanic planets. So we know that the planet is 6.5 times more massive than the Earth is, and it also has a radius 2.5 times longer. But the thing is that this planet is not in the habitable zone. It is close to its parent star, so the temperatures are at around 100 Celsius or less. So this would not really allow for an ocean, because it would just turn into vapor. But if it is actually colder, then it does possibly have it. Still, NASA reported that they may have detected clouds on the surface of the planet. But what is also a possibility is that it is a very hydrogen-rich atmosphere with a rocky surface. It would be like a transition between a gas giant and a terrestrial planet. So there are almost all the planets that are possibly oceanic. As we can see, there are a few of them, and we should expect even more discoveries and even more promising water worlds. But in general, we are just here to observe them for now. We are not visiting them anytime soon, as they are tens of hundreds of light years away. So light speed, fastest speed possible, takes that many years to reach them. And we are nowhere near as close to traveling that fast. We haven't even reached